solve 2x squared minus 15x plus 18 is less than 0. So you can see that the left hand side is a quadratic function and the graph is usual parabola, and if you know roots, you can see that we need the value of this function, and it means what y values should be what, less than 0. Where is it? If you know roots, you can see that the solution is in between from x1 to x2. So we need roots, and let's use discriminant. 2x squared minus 15x plus 18 is 0. Discriminant is b squared. Negative 15 squared is plus 225 minus 4 is c. And it's 225 minus 144, which is 81. And roots are minus b, so 15 plus minus root of d, it's 9 over 2a. It's 4. So 4 plus, it's 24 over 4, it's 6. For minus, it's what, 6 over 4 or 3 over 2 or 1.5. And hence solution is for x, we need strictly less, so x is strictly greater than 3 over 2 and less than 6. The next, b, the function f is defined by f of x is square root of this expression, but you can see that it's absolutely the same. Find the greatest value of k for which the inverse exists, justifying your answer. So first of all, this function, since it's a square root, has a domain, and 2x squared minus 15x plus 18 must be greater or equal than 0. It's due to domain. And also function inverse to exist, function must be 1 to 1. Inverse to exist, and from the previous result, roots are 3 over 2 and 6, and due to domain, this, and it's actually what y values of a function must be greater or equal than 0, so we should choose these parts, because from 3 over 2 to 6 y values are negative, but here we need to be positive, and function to be 1 to 1, it means always increasing or decreasing, inverse to exist, and we need, you can see, x to be less or equal than k, so we just consider this part from 3 over 2 and to the left, and you can see that function is always decreasing, and it's 1 to 1, and hence the inverse exists. So x is less or equal than 3 over 2, so k is 3 over 2. And actually you can see that just domain is x less or equal than k. It cannot be this part at all, because there is a gap here and it's impossible. You cannot say that x is less or equal than 10, for example, but there is some gap in somewhere within domain. So just due to domain, we can say that x is less or equal than 3 over 2, and for this region function is 1 to 1, so inverse exists. And again, why it must be 1 to 1? Because if you consider, for example, usual parabola, inverse is symmetrical about y is x, and it looks like this, but it's not a function at all, because if for x there are 2 or more values of y, for at least 1 point, it's not a function at all, and that's why we consider just a part, so that function is one-to-one. Here function is not one-to-one. One-to-one, it means for one x there is only one y value, but here you can see that there is at least 1 point for which for two x values we have the same y value. It's a many-to-one function, or we say that this function fails horizontal line test to check whether it's one-to-one. So if it's one-to-one, there will be only this part for inverse, and hence inverse exists. So that's all for this question.